Okay, so let's start off with a few different compounds. First I have this. Make sure I write it out completely. Okay, so the first thing we take a look at is what is the highest priority group, and to make sure that we include this highest priority group in our longest continuous carbon chain. So our longest continuous carbon chain is going to include this aldehyde group. So longest continuous chain, highlighted in yellow, is 4 carbons long. A 4 carbon long parent chain for alkanes is butane. Because this is a aldehyde, we drop the E and butane switches over to butanal. No need to put a 1 in front of it because the 1 is given. The aldehydes are terminal at the end of the carbon chain. So all we need to do now is just label out our substituents, if we have any, which we do. Our one substituent on this chain is this methyl group highlighted. So to finish off the naming of this compound, we put the name of the substituent and its carbon number location, and then put butanal. So before we name it off, let's make sure we get the appropriate carbon numbers. 1, 2, 3, and 4. Carbon 1 always goes on the carbonyl carbon. In this case, on the carbonyl that's part of the aldehyde group. So our methyl group is part of carbon 3. So naming our compound, substituent 3-methyl, no other substituents, so we just latch on the parent name, butanal. So the name of this compound is 3-methyl butanal. Let's take a look at another compound. Okay, in this compound, the first thing we do again is establish the highest priority group and make sure that group gets on the longest continuous carbon chain. Our one and only functionality in this molecule is actually the carbonyl ketone. That's our highest priority group, so we make sure to include it in the longest chain. There is a single chain that is 5 carbons long. This is highlighted again in yellow. A 5 carbon alkane chain would ordinarily be pentane. But since this is a ketone, where we drop the E at the end and add ONE, pentanone. Last thing we do in the case of a ketone is to identify where the carbonyl carbon is. So we make sure we number our chain so that the carbonyl carbon gets the lowest carbon number. In this case, with this molecule, it doesn't matter whether we number left to right or right to left. Either direction gives us the lowest possible carbon number for that carbonyl carbon of 3. So we just put this identifier of which carbon the ketone is located at in front. So 3-pentanone is the name of our final compound. Okay, let's continue on with a few more compounds that we will identifying name. Okay, first compound here. Again, identify the longest continuous carbon chain, along with making sure that the highest priority group is included in that longest continuous carbon chain. Our highest priority group here is the carbonyl ketone. The longest continuous carbon chain that includes that carbonyl carbon is 1, 2, 3, 4, 5, 6, 7 carbons long, as highlighted in yellow. We were numbering out these carbons. We make sure to give the carbonyl carbon the lowest possible carbon number. So we're going to number from right to left. That enables us to give the ketone carbonyl a carbon number of 2. There are no substituents actually in this compound, so no need to name off substituents. 7 carbons is ordinarily heptane. Since this is a ketone, we will drop the E ending for an alkane and add -one. This lets us know it's a ketone. Now the last thing we need to do is just identify where that ketone carbonyl is located along that 7 carbon backbone. So we labeled it the lowest possible carbon number 2. So this will be 2 heptanone. So this is the name of our final compound. Okay, next one. We'll try something different here. Okay, again, the first thing we do is identify the highest priority group and make sure to include that in the longest continuous carbon chain. For this compound, we have a cyclohexane ring with a carbonyl carbon, a bromine, and a hydroxyl OH hanging off of it. The highest priority group, according to our priority listings, is the carbonyl carbon, which is higher in priority than our hydroxyl OH or the bromine. So we'll make sure to just include the carbonyl in our longest continuous chain, which is actually 6 carbon cyclohexane ring. And we'll make sure to give the carbonyl carbon our lowest possible carbon number, so that will get carbon 1. Now the question becomes, which direction do I go, clockwise or counterclockwise? Well, the next highest priority group is the hydroxyl OH. That's higher in priority than the bromine. So when we number our ring, we'll make sure to give the hydroxyl the next lowest carbon number. So it's going to get carbon 3, and as a result of our numbering, our bromine is going to go on carbon 5. So 6 carbon ring, ordinarily cyclohexane for an alkane. This is a ketone, so our cyclohexane switches over to where we drop the E, and it becomes cyclohexanone. No need to put a 1 in front because of the fact that it has the lowest possible carbon number. Now, we just identify the substituents, which we did earlier. Our hydroxyl OH on carbon 3, and our bromine on carbon 5. For naming this compound, we name off the substituents in alphabetical order. That will start with the 5, bromo, then 3, hydroxy, and then straight into the parent name, cyclohexanone. So this is the final name of our compound, 5-bromo-3-hydroxy-cyclohexanone. Okay, continuing on with some other compounds to identify. We'll make one slightly different here. Okay, so this is our compound. Again, the first thing we do is identify the highest priority group and make sure to include this in our longest continuous carbon chain. Our highest priority group here is the carbonyl aldehyde on the left-hand side. Our longest chain is actually starting from making sure to include our carbonyl carbon, goes down to the bromine and then continues on down for a grand total of 1, 2, 3, 4, 5, 6 carbons long. We make sure to include the carbonyl carbon. We give this our lowest possible carbon number, which for an aldehyde is always going to be 1, 2, 3, 4, 5, 6. So this is a 6 carbon aldehyde. Our substituents that we have, there are 2. We have a methyl group located at carbon 3 and a bromine located at carbon 4. So for naming, 6 carbon chain, if it's an alkane, would be hexane. Since we're dealing with a aldehyde, that drops the E and we switch over to hexanal. So this is the name of our parent chain. No need to put a 1 in front. It's implied that the aldehyde is at the carbon 1. So now we just need to name the 2 substituents. We put bromine first because it's first alphabetically. 4 bromo, followed by 3 methyl, the other substituent, and then we just add our parent name, hexanal, at the end. So this compound is 4-bromo, 3-methyl hexanal. Let's go ahead and move on to another compound. This one here. Put a few things in there. Okay, so for this compound, again, just like any other, what is the highest priority group? And make sure we put this highest priority group in the longest continuous carbon chain. Our highest priority group in this molecule is actually the carbonyl aldehyde on the right-hand side. The alcohol OH is lower in priority, so in this case the OH hydroxyl is a substituent and not the highest priority group. This is not an alcohol, this is an aldehyde. So longest continuous carbon chain that includes the aldehyde carbonyl is going to be 4 carbons long. Now note that the 4 carbons that I made the longest continuous chain includes the hydroxyl OH alcohol at the very end. Now this is preferred over going 4 carbons from the carbonyl carbon down 4 carbons as well to just a alkane chain. So in naming this compound, just make sure we assign the proper carbon numbers. Carbon 1, lowest possible carbon number goes on the carbonyl aldehyde. And we number out to carbon 4 where the hydroxy OH is located. Our two substituents are the hydroxy at carbon 4 and the ethyl group at carbon 2. In naming this compound, 4 carbons long would be a butane for an alkane. Since this is an aldehyde, we drop the E and butane becomes butanal. Again, aldehydes are terminal, so there's no need to place a 1 in front. 1 is implied. So now all we need to do is just place the substituents in front of the parent name. Of our two substituents, ethyl goes first alphabetically. So this is 2-ethyl. Next substituent, 4-hydroxy. And then we put our parent name right after it, butanal. So the name of this compound is 2-ethyl 4-hydroxy butanal. So let's wrap up our tutorial on naming aldehydes and ketones with two last structures. This one identify the parent chain and make sure to include the highest priority group in that parent chain. This is actually just a cyclohexane ring, so that's our parent chain of carbons, the longest continuous, and those have included our highest priority group, which among these functional groups hanging off the ring we have 2 carbonyl ketones and 1 hydroxy OH. The carbonyl ketones have a higher priority than that of the hydroxy OH. So we make sure when we number our carbons to give these 2 carbonyl ketone carbons our lowest possible carbon numbers. To give them the lowest possible carbon numbers and give our one substituent, which is our hydroxy OH, the next lowest possible carbon number, we will make sure to label carbon 1 at the top of the ring. This gives the other carbonyl carbon a carbon number of 3 and the hydroxy OH a carbon 4 number. So in naming this compound, parent chain cyclohexane, because we're dealing with a ketone, this is going to be dropping the E. Ordinarily if it was a single ketone, but since we are dealing with 2 ketones, we say cyclohexane. What ordinarily would be a drop in the E to add "one," we keep cyclohexane and just add dione at the end. This indicates that we have 2 ketones. In front of the parent name, we designate what carbons those 2 ketone carbonyls are located. So we place a 1 and a 3 to let us know that the ketone functionalities are at carbons 1 and 3 along the ring. And then to finish off, we take this parent name and place the one and only substituent, our 4-hydroxy, in front. Then our parent name, 1,3-cyclohexane dione. So the complete name for this compound is 4-hydroxy 1,3-cyclohexane dione. Okay, so here's our last compound that we're going to be looking at. course, the last one is going to be the most challenging one. Okay, so in this compound, again, maybe more complex looking, but we still break it down the same way we do all of our other compounds. Longest continuous chain that contains the highest priority group. Well, we have a carbonyl aldehyde on the right, a hydroxy OH alcohol in the middle, and an aromatic 6-carbon benzene as well. Make sure to include the highest priority group in the longest continuous carbon chain. This will be actually longer number of carbons than that of the benzene. It will be 7 carbons long, 1 starting at the carbonyl aldehyde and reaching all the way out to the end of our chain. Since it's 7 carbons long, this makes our benzene ring a substituent and not part of the parent chain. So this will come into play when we name our compound. Our substituents off of this parent chain, like we said, is the benzene ring. A couple methyl groups over here. The hydroxy OH, and then what appears to be a ethyl group as well. So to name this compound out, we make sure to number our 7-carbon parent chain with the lowest possible carbon number going to the highest priority group, which is our aldehyde carbonyl. This will make it 1, 2, 3, 4, 5, 6, and then the last carbon out is 7. In naming this compound, 7-carbon parent chain for an alkane would make this a heptane. Since we are dealing with a highest priority group that is an aldehyde, we drop the E and heptane becomes heptanal. No need to put a 1 in front of the parent name since aldehydes are terminal or ends of the carbon chain, so no need to include a 1 in front of the parent name. Now that we have our parent name, we list out our substituents in alphabetical order, indicating their carbon location. So first in alphabetical order is our ethyl group. Our next substituent that has the next in line in terms of the alphabet is our 4-hydroxy. Next, we actually have our 2 methyl groups on carbon 6. Since there are 2, we list out 6,6 and place the Greek prefix di in front of it, 6,6-dimethyl. And then lastly, our final substituent is the benzene ring. Whenever benzene becomes a substituent, the name changes to phenyl, Phenyl. Now that we have the substituents, we just place the name of the parent after it, heptanal. So this compound, in all of its glory, is 3-ethyl, 4-hydroxy, 6,6-dimethyl, 5-phenyl heptanal.